Electricity. It's a daily necessity that powers our lives and our work, but it can also pose significant dangers when not handled correctly. Did you know that, on average, over 40 people across the US are injured at work each week due to electricity? Or that about 165 people lose their lives each year to electrocution? What's even more surprising is that nearly 70% of these deaths happen in non-electrical occupations. Electricity doesn't discriminate. It can be just as dangerous for a construction worker or an office employee as it is for an electrician. So whether or not you're working directly with electricity, understanding basic electrical safety is critical. To help ensure worker safety, the Occupational Safety and Health Administration, or OSHA, provides comprehensive electrical safety standards for both general and specific industries. But it's also important to note that there may be additional state-specific regulations to follow. While this training provides a general overview, it's crucial to understand and follow the specific rules and regulations that apply to your line of work. In this training, we'll cover everything from the basics of electricity to the hazards of electrical shock and how to respond to an electrical accident. We'll also learn how to recognize and mitigate electrical hazards at work so you can stay safe on the job. Let's get started. Let's start by understanding some electrical basics. The three primary concepts to know are voltage, current, and resistance. Voltage is the driving force that pushes electric current through a conductor. Think of it like water pressure in a hose. Current is the flow of electricity in a circuit, like the rate of water flow. And resistance is what opposes the current, like friction in the hose. Electricity travels along conductors, which are materials that allow an electrical current to flow easily. Metals like copper and aluminum are excellent conductors. On the other hand, insulators are materials that resist electrical flow. Rubber, ceramics, plastic, and drywood are good examples. Of course, water is also typically a conductor, which is why using electrical appliances around water can be so hazardous. That also means water can turn a usual insulator into a conductor, like wet wood versus dry wood. So it's especially important to use caution in wet or damp conditions. Lastly, the ground or earth also acts as a vast conductor. It's a significant factor in electrical safety because it can efficiently absorb or lose electrons, which are the charge carriers in a circuit, allowing electricity to flow easily through it. This principle plays a key role in grounding safety mechanisms that we'll explore shortly. Now imagine a simple circuit with a battery, a light bulb, and connecting wires as our conductors. When the circuit is closed, meaning there's an uninterrupted path, energy flows from the battery through the bulb and back to the battery. This is how many of your everyday appliances work. So in a circuit, electricity is always seeking the path of least resistance to make its way back to the source. So imagine if you accidentally touch an exposed wire. Your body can provide that path for the electricity to travel through you into the ground and back to the source. Some energy could still flow through the device, but a good deal more will find its way through you. This is where the safety mechanisms of insulation and grounding come into play. Insulation is the protective barrier that surrounds conductors, designed to keep the electric current on its intended path. When the insulation is damaged or missing, the electrical current may find a new, unintended path, like our bodies, leading to an electric shock. On the other hand, grounding involves connecting an electrical system to the earth, providing a direct alternative path for the electric current to follow. So, if there's an issue with the circuit or a breach in the insulation, the electricity will more easily follow this low resistance path into the ground rather than passing through a person. Essentially, the grounding system takes the hit, not you. Other safety devices like ground fault circuit interrupters, circuit breakers, fuses, and surge protectors all help prevent electrical mishaps. These devices can detect overloads and imbalances in electric current and quickly break the circuit to prevent a shock. In our next section, we'll dive deeper into what happens when you accidentally become part of an electric circuit and the emergency response required during electric mishaps. All right, Now that we've covered the basics of electricity, it's time to dive into the risks, like the effects of electric shock, high versus low voltages, electrical fires, and what to do when faced with an electrical emergency. The effect of an electric shock ranges from a tingling sensation to a fatal injury, depending on the strength of the current, the path it takes through your body, and how long exposure lasts. Serious shocks can cause heart attacks, nerve damage, severe burns, and even stop you from breathing. The shock can also trigger involuntary muscle contractions, leading to secondary injuries like cuts and falls. Now on that note, working at height adds another layer of danger. Being shocked while on a ladder, scaffolding, or elevated platform can lead to an involuntary reaction and a fall, even if the shock itself isn't life-threatening. So take extra precaution when working with electricity at height and never use a metal ladder. Instead, go for non-conductive alternatives like fiberglass, wood, or insulated ladders designed to protect against electrical hazards. Next on our list, power lines. Both overhead and buried lines carry a hefty punch of voltage and are extremely dangerous. If you or your equipment make contact with one, you risk burns, falls, and electrocution. Assume every power line is live and keep a 10-foot distance for yourself and all equipment. That includes tools, cranes, trucks, and tall equipment like ladders. This distance increases by 4 inches for every 10 kilovolts over 50 kilovolts. You may check for exceptions depending on special conditions, but these are the general safety provisions. If you're digging, always check with utilities for the location of buried lines. Take special precautions like having lines de-energized or grounded, and use non-conductive tools and barriers whenever possible. High voltage and low voltage refer to the amount of electrical pressure. High voltage, like power lines, is rated at tens of thousands of volts. Low voltage, under 1,000 volts, is what we see in household appliances. Think of it like a waterfall versus a stream. Now you might think high voltage equals high danger and low voltage equals low danger, right? Well, it's true that high voltage is more powerful, but low voltage can also lead to a dangerous condition called freezing. This is when your muscles involuntarily contract, locking you onto the electrical source. In this way, freezing can lead to longer exposure and serious injury. So, safety isn't really a question of high or low voltage, and all electrical lines should be treated as dangerous. If you see someone receive an electrical shock, knowing what to do can make all the difference. Before jumping into action, make sure you won't become a victim yourself. Never touch the person who's being shocked, or you might get shocked too. If you can safely do it, turn off the source of electricity. This will stop the flow of current and potentially save their life. If you can't switch off the power, try to separate the victim from the electrical source using a non-conductive object, like a wooden pole or broom. As soon as you can, call emergency services for help. Explain the situation clearly and follow their instructions. If the victim is unconscious and not breathing, perform CPR. If they are conscious, reassure them that help is on the way and keep an eye out for any secondary injuries. Lastly, wait with the victim until professional help arrives. Electrical accidents can also throw sparks that ignite combustible materials, including things like chemicals, paper, and dust. You should keep a clean, clutter-free workspace to reduce this risk. Also, be aware that fighting an electrical fire requires specialized firefighting equipment, and never use water. It's a conductor and can make a dangerous situation even worse. Now, when it comes to electrical accidents, there are typically 3 main culprits: unsafe equipment and installations, unsafe environments, and unsafe work practices. Unsafe equipment and installations are situations where the equipment itself presents the risk. This could include exposed electrical parts, overloaded circuits, misuse of extension cords, and worn-out insulation. Exposed electrical parts, like a tangled mess of wires, cables, or connectors left uncovered, can become a direct route for electric shock. To prevent accidents, make sure all electrical equipment is correctly installed with protective barriers, like panel enclosures and clear signage to alert others of the electrical hazard. Wires with frayed insulation can also cause unexpected electrical shocks. Be sure to regularly inspect your wires and replace them when needed. Be mindful not to install wires where they can be easily damaged or worn, like high traffic areas and doorways or near sharp edges. Extension cords are designed for temporary use, not permanent wiring. Regular reliance on them can lead to cord damage and overheating. If you find yourself constantly using an extension cord, it might be a sign that you should install more permanent wiring or outlets. Circuits can become overloaded when too many devices are plugged into one outlet. This can both damage your devices and lead to electrical fires. Signs of an overloaded circuit include flickering lights, frequent tripped circuit breakers, warm or discolored wall plates, and the smell of burning insulation. Be sure to spread out your devices across multiple circuits, and if you're regularly short on outlets, consider having more installed, potentially with new branch circuits. Keeping your work environment safe is also an important part of preventing electrical hazards. An unsafe environment for electrical equipment includes places with excessive moisture, poor ventilation, flammable material, or poor housekeeping practices. As we've learned, water, including moisture, humidity, and even sweat, can create a more highly conductive path for electricity. For example, dry skin is less conductive than moist skin or an open wound. So, make sure your work area, electrical equipment, tools, clothing, and skin are all kept dry. If your work involves operating around or underwater, make sure your equipment is specially designed for these conditions. Poor ventilation can also cause heat to build up from electrical equipment, leading to overheating and fires. To mitigate these risks, make sure there's consistent, adequate ventilation around all electrical systems and that it's regularly inspected and maintained. As mentioned previously, electricity can also generate heat and sparks that can ignite flammable materials like chemicals, paper clutter, or excessive dust. So be sure to keep the area around electrical equipment clean and maintain a safe distance from any flammable materials. Lastly, poor housekeeping can lead to all sorts of hazards, including electrical accidents. Tripping on cords can cause injury, damage wires, and expose electric parts. Accidental spills can turn surfaces into conductors or even lead to fires, depending on the substance. For these reasons and many more, it's important to keep your workspace organized, clean, and clear with a job site housekeeping plan that ensures accountability. And of course, always secure loose cords and clean up spills promptly. Unsafe work practices often involve disregarding established safety rules and protocols, which can lead to serious electrical accidents. To ensure your safety, always follow safety procedures, heed warning signs, and exercise caution around electricity. Ensure only qualified persons work directly with electricity. Keep equipment in good condition with regular maintenance. Always power down equipment before inspection or repair. And use lockout or tagout procedures to ensure the equipment is properly shut off and can't be re-energized until maintenance is complete. And always wear the appropriate personal protective equipment when working directly with electricity, like insulated tools, gloves, sleeves, shoes, and hard hats. We've covered a lot of ground in this training, so let's recap some of the main points. We started with the basics of electricity, introducing the roles of conductors and insulators, how electricity flows in a circuit, and how safety mechanisms like insulation and grounding help to safely manage that flow. From there, our focus shifted to the risks associated with electricity, the health effects of electric shocks, secondary injuries, the dangers of working at height or near power lines, the hazards of high and low voltage, and the concept of freezing, which can lead to prolonged exposure. We outlined emergency response to an electrical accident, like cutting off power and insulating yourself before helping a frozen victim. On the risks of electrical fires, we highlighted the need for specialized firefighting equipment and the importance of never using water to put out an electrical fire. In the last section, we focused on recognizing and mitigating electrical hazards, honing in on the three main culprits of electrical accidents: unsafe equipment and installations, unsafe environments, and unsafe work practices. Preventative measures were covered in detail, including regular equipment inspection, the necessity of keeping workspaces clean, dry, and ventilated, and adhering to safe work procedures, like de-energizing equipment before maintenance and the use of personal protective equipment. Remember, understanding these basic principles is just the first step. The true key to electrical safety lies in applying this knowledge in your everyday work, always being mindful of potential hazards and never underestimating the power of electricity. While the principles of electrical safety remain the same, how you apply them can change based on your specific working environment and circumstances. So it's important to be aware of your own job site safety practices in any industry, specific training, or precautions. By following your worksite's specific safety procedures and continuously learning, you're contributing to a safer work environment for everyone involved.